Okay, today this video is just going to review what we talked about on Monday, where we're looking at personal expenses and looking at what we can do with that data. So we should be able to graph bivariate data, interpret patterns and trends, make a scatter plot, find an equation of a line of best fit, and then make predictions with that. So, it depending on what you had for Algebra 2 last year, some teachers would have done this, other teachers didn't. But, you know, what we're looking at is past trends can predict future occurrences. So we can look at data and predict, hey, what's going to happen next week, next month, next year. So univariate data, which is what we've been like finding the mean, finding the mode, finding the variance, that is a single set data. So like I gave you the cell phone bills of 12 people. That's one thing. Bivariate data is going to be data represented by pairs of numbers, which really what that gives us is ordered pairs that we can then plot on a coordinate plane. I could give number, which is something that you're going to do eventually, number of absences, and then your grade. So I would have for everybody an X and a Y. Okay, that is bivariate data. If we look at this data, what we're going to do with it is make a scatter plot, which, I'll show you in the next thing, but that's like my X, my Y. And I'm plotting points. So I have my x-axis, which is my independent variable. My y is my dependent variable. Could be. They might not depend on each other. But you plot your x, you plot your y. You're looking, is there a trend? Well, are the dots going up? Are the dots going down? Are there dots all over the place? That really is correlation. How are those variables related? So if I show this screen just as examples, scatter plot is a graph of a set of data points, x comma y. Correlation describes how they are related. We have positive correlation, dots are going up. Negative correlation, dots are going down. No correlation, dots all over the place. So we looked at, if I said something like this, does the amount of time you spend studying and the amount of time you have to spend with your friends. Well, if you think of this as time study, and this is time you spend with your friends, if you think of it as you have more time studying, you should have less time to spend with your friends. If you have less time studying, you would have more time to spend with your friends. So that would be negative correlation. If I said the time you study and the score on a test, well, again, if this is time and this is score, I would hope that the more time you study, the higher your score is. So that would be positive. But then just in real life, the amount of time you spend studying and the size of your shoe, well, that shouldn't be any relationship whatsoever. So that's no correlation. Just to give you an idea. So If a scatter plot shows a linear trend, you can find an equation of a line of best fit. So we are going to go back and do a little bit of algebra. Now, what are the two things that I need from Algebra 1 geometry and Algebra 2? Slope of a line. You have 2 points, y minus y, x minus x. The other thing, point slope. How do you get that equation? Y minus y sub 1 equals m times x minus x sub 1. So we're going to be plugging in the slope and then a point. So just as an example before we really do the math part. So Ravi is a 16-year-old. He has a part-time job after school. He's looking to see if there are any trends that relate monthly income to monthly clothing purchases among his peers. He thinks they might be related. So he has XY. This is income, and this is money spent on clothes. So, you can look at, does income, as it gets bigger, do people spend more money on clothes? Well, you would think that the more money you have, possibly the more you would spend. So you could make a scatter plot of that data. So you could then make a prediction on if someone had $250, how much would they spend in a month? So you want to be careful when you make your scatter plot, which we would have done this yesterday in class. If this is income, which X is horizontal, and this is money spent, look at your numbers. They're like 200 to almost 400. So, maybe you go by 50s, but you have to go by equal intervals. So like I'm going by 50s, and I could keep going, etc. My money spent on clothes is like 36 to 84. So maybe I go by tens, 10, 20, 30. And when you guys make these, they are going to be, a lot of you don't have graph paper probably, so they're going to be, approximate graphs. So how do you plot that point? 205, 36 would be like there. 242, 45 would be there. And you just plot your points. Now, if I go back to this question that says, if someone has 250, how much do you predict they might spend on clothing? You could look at your scatter plot and you could say, okay, well, 250, if I would have done 268, they were up at 57. I could have just sort of made and thought, okay, 250, well, that's about $48 or $50. So I can use that trend to predict. For many people, the cost of contact lenses is a discretionary expense. So he finds the type he needs, 6 lenses to a box, and you can see that if I buy 1 box, $6, 2 boxes, $5.90, 4 boxes, $5.40. So we look at that, and hopefully you see that the more boxes you buy, the price goes down. So if you thought of this is boxes, this is price. 1 box, it's up here at 6. 2 boxes, it's lower. 4 boxes, which you would have to go by equal intervals. But, your price is dropping. So you could answer questions. What do you notice about the number of boxes purchased and the price per lens? More boxes I purchase, the price is lower. The explanatory variable and the response variable, don't really worry about that. Now, if I gave you this scatter plot, hopefully this is the number of coffee purchases and the grade point average. Well, hopefully you don't see anything. You can't say they're going up, they're going down, but should the number of coffee purchases have anything to do with your grade? Not really. So you would say no correlation. Price of a cell phone purchase and the tax on that purchase. They made a scatter plot. Would you think as the cell phone price goes up, would tax go up or would tax go down? Well, as the price goes up, the tax should go up. If they both move in the same direction, positive correlation. So, line of best fit. This is what I want to make sure. You could have gone to this if this is what you want to make sure that you know how to do. So, we're going to make that scatter plot. We're going to sketch a line that we think best follows the data. We're going to find 2 points on our line. And we're going to find the slope. So y minus y over x minus x. We are then going to find the equation using our points, which is point slope. You'll plug in m, and you'll plug in with one of the points an x and a y. So those would be the 4 points. Then you can use predictions to go from there. So what I have, and I actually did it, and I'll just, I'll erase on the next slide, but we looked at hours spent studying and GPA. So you would think that the more you study, the higher your GPA should be. It should be positive. Okay, so first thing, I would look at that data, and I'm just going to erase, actually I'm going to erase just the line. So I'm going to erase all that. Not the grid though. So I want to get rid of all of my writing over here. So when I look at this, first thing I do, make that scatter plot. Look at your x's, look at your y's, pick something to go by. My x's was hours spent studying, and I went by, I went by 5s really with this grid, but I just wrote 10s. And then GPA, well, the highest GPA, I guess it must have been weighted, so you could have gone over a 4.0. So I went 0.51, 1.5, etc. So the first thing I'm doing is I'm just plotting those points. So, you look at what I did. I plotted 14, 3.91. I went to 14, which would be about there. I went up to 3.91, which was about 4. So that's really the one that I got erased. 5 hours was a 2.0. And I think 10 hours was a 3, which I got. So there's my data. Now, what's my next step? Draw a line that I think best fits that data. So there's my line. Now I got to do the math. So in order to do the math, I'm going to move that off and go back and put it after this so I can show you the math there. I need to pick 2 points on my line. Now you notice I don't really even have any of the dots, but this would be a nice number. 15 hours, I got a 3.0. And another one that looks like a good one is, at least this is pretty close, 25 hours, I got a 4.0. So I did my x, y, x, y. I'm going to find my slope. Y minus y over x minus x. So I get 1 over 10. Make it a decimal, 0.1. Now use point slope. Y minus y equals m times x minus x. Pick a point. Y minus my y is 3.0. My m is 0.1. Parentheses x minus 15. Now work through that. Distribute. Y minus 3.0 equals 0.1 times x. And if I take 0.1 times 15, so I'm distributing, I get minus, because that's negative, 1.5. Add 3, and that gets added to the 1.5 that's negative. And there is, if you do negative 1.5 plus 3.0, you get positive 1.5. There is your line of best fit equation. So how would you use it if I find that equation as that? I could say, okay, let's say someone studies 35 hours. If they study 35 hours, what's their GPA? Well, that means X is 35. You could look on your graph, but I want you to use the equation. 0.1 times 35 plus 1.5. So what you would then do is just put that in your calculator. 0.1 times 35 plus 1.5. You should get as your GPA a 5.0. Can't go much higher because you can't go higher, but that is line of best fit. Make predictions with your equations. And that's really the other examples we went over yesterday. I wanted to just make sure more than anything I did an example of the math and you being able to look at those. So hopefully that helps.